Suppose we only have a frequency distribution and we don't have the actual data. So let's say, for example, we're given the frequency distribution here, but we are not given our actual data. We still may want to find out what the mean of our data set is, and we can talk about something called a modal class. For grouped data, we have to do a little bit of work. For the mean, the median, and the mode, there are simple formulas in Google and Excel that we can use to find them given our original data set. But given a frequency distribution, we cannot use those formulas. So let's see how we can use the information from our frequency distribution table to come up with an estimate of our mean. It's not going to be the true mean. It'll only be an estimate. Because we don't have the data, we only have approximations of the data in this frequency distribution. So the first definition that we need is something called a modal class. A modal class for a grouped frequency distribution is the class in the frequency distribution with the largest frequency. So if we're looking at this example of a frequency distribution, I look for the largest frequency, which is 24. So the modal class is 125 to 174. We would use the label of the class, not the frequency. We want to know, where do the values sit? What is the range of numbers that has the most frequency? So our modal class is 125 to 174. In order to find the mean for the grouped data, so this is only for a grouped frequency distribution, I'll write the formula here on the side and then we'll work through how to do this by hand. The mean for grouped data is that we're going to take our frequency times our midpoint, frequency times midpoint, add them all up, and divide by the total number of data values. You can think about it this way. I'm going to do a simple example on the side and then we'll tackle this one. Let's move over here. If we had a set of values with repetition like this one, instead of just adding 5 plus 5 plus 5 plus 3 plus 3 plus 3 plus 3 plus 6 plus 8 plus 8, we can use arithmetic to shorten this process. There are 3 5s, so we could say 3 times 5. There are 4 3s, so we can say 4 times 3. There's only 1 6, and there are 2 8s. These values here are the frequencies in which these other numbers are occurring in the data set. So 5 occurs 3 times. Instead of adding them 5 plus 5 plus 5, we can just say 3 times 5. Then, when we add them up and divide by how many we have, we're finding the mean in the exact same way as we would if we just added up the top row. This principle is exactly what we're using with this grouped frequency distribution. In the grouped frequency distribution, we have a range of values given by each class label, 75 to 124, 125 to 174, 175 to 224, etc. And we have frequencies that go along with each one of these. There are 11 numbers sitting between 75 and 124. We can't just pick any number in that range. We should pick a reasonable number in that range. And the reasonable number that's settled on is the midpoint of the class. So our midpoint of the class here, 75 to 124, add them up, divide by 2, we get 99.5. We'll do the same thing with 125 and 174. Divide by 2, we get 149.5. And we can keep doing this all the way down. So we're adding 125 plus 174, divide by 2, and we get 149.5. And we can keep doing this for each one of these classes, or we can remember from the previous chapter that the width is exactly what separates all of these midpoints. And our width here is 50. So adding 50 to each one of these numbers will get us the midpoint for each of the classes in the data set. And again, a reminder, we can get the width by looking at successive lower class limits, successive upper class limits. Both of those in the table will give us the width. Okay, so we have our midpoint and we have our frequency. So then the next step is to multiply. Frequency times midpoint. And we'll get a number. Frequency times midpoint. I'll multiply those out. And we'll get this frequency times the midpoint here on the side. And then the next step is to add them all up. So we're going to add these 5 numbers together. And we get 8,025 for the total. To find the estimated mean for our grouped data, we'll take that total, 8025, and divide by our n, which in this case is 50, because we had 50 values in our grouped frequency distribution. And if we do that division, we get 160.5 for our mean. Now, yes, this does take a lot of time. Grouped frequency distributions and finding the mean does take a little bit of time. We are going to make use of Google and Excel so that our formulas go a little bit faster and we have an easier calculation. Instead of punching them into the calculator, we can just use the power of the technology and allow Google Excel to add, divide, multiply for us pretty efficiently. Okay, here I am in Excel, and we're going to walk through how to find the mean for the grouped frequency distribution for the drive-through service times. Exactly the same one that we have in our notes. Now, even though I'm using Excel, exactly the same steps can be used in Google, and you will see the same results. So I'm going to start out by defining our midpoint column, and then we'll do F times XM. So our midpoint, I'm going to get Excel to calculate it, 75 plus 124, and divide by 2. There's my 99.5. Now, we could do this for every one. 125 plus 174 divided by 2. For this one, I do have to type them all in because I do not have an easy way of getting these numbers out of that first column into the third one. Or, remembering that the width separates these midpoints, take that number, add 50. And if I do that, I can drag the formula down like we've seen before and copy it over. So I get the same midpoints that I had before. Then for the frequency times the midpoint, we're going to use those cell references. Equals frequency times midpoint. You want to make sure you're multiplying in the same row. 11 times 99.5. There's that 1094.5. I'm going to grab that handle and drag it down so that I copy that formula and it automatically adjusts all the way down. And we see the same values we saw in doing it by hand, which is great. And then down here, we'll do a quick sum, SUM sum. If we add up these numbers, there's my 50. So I'm going to do that over here because I need to add frequency times midpoint. There's my 8,025. And then to find the mean, I can take the 8,025, divide by the frequency, the total frequency, 50, and there's my 160.5. The technology is intended to make these calculations easier than using the calculator and working by hand. And the goal here is more that we interpret and understand what that mean is, 160.5, instead of getting so bogged down in the calculations. So this class is a little different from traditional math classes in that the emphasis is not on the calculations themselves, but on understanding what that number means. So looking at this data for drive-through service times without having the original data and only having this grouped frequency distribution here, we would say that the average wait time is 160.5 seconds, a little under 3 minutes. I know this isn't exactly represented in the notes, but I do want to walk through and show you a comparison between what we just calculated using the grouped frequency distribution and the mean of 160.5 to find out what the true mean of that sample is. Here we have the original data that we used to create that group frequency distribution back in Chapter 2. So I can calculate some things. Mean, median, mode. I'll label them so that we can compare them. Okay? So to find the mean, both in Google and Excel, we actually don't use the word mean. The formula is average. So we would type the word average, and then I'm going to use my mouse, come up here and select all of my data. And I can do it as a big block just like that. I don't have to worry about them all being in the same row or all being in the same column. I just grab the block of data. Hit enter, and there's my mean, 160.24. Our grouped frequency distribution mean of 160.5 is actually really close to our true mean of 160.2. We would round that to 1 decimal place, so I'm going to decrease my decimal here so that it matches my rounding rule, 160.2. To find the median, we do use the word median, and we'll grab that data again. So equals median, grab the data, hit enter. Our median is 150. And then for our mode, we can actually type the word mode. Mode alone is a little outdated. So they have 2 more. They have one for the possibility of a multimodal set or a unimodal set. Since I don't know, I'm going to try the multimode because the multimode will actually turn only a single mode back if there is a single mode. So it kind of works well for both situations. And I'll grab all the data. I only have one mode. 197 shows up more than once. And glancing at the data, I see one here and here, and that's all I see off the top of my head. So I do have one that shows up twice. So we have these 3 measures of center, and then we have the grouped mean of 160.5. And the idea here is when we have all of these different measures of center, we want to be able to understand them, and we also want to be able to talk about which one is considered the best representation of the center of the data. And this may come in the context, in particularly what types of numbers we have. And you can see some more examples. For this data set in particular, we could possibly make an argument for both the mean and the median. They aren't that far off, but when we have a data set that's really spread out, one value could be more meaningful than the other. So we'll take a look at that in another lesson.